Okay, we're talking about section 12.1, and we're going to go over a few problems. Let's start with number 11. With number 11, that focus doesn't look so good, does it? That's much better. Okay. Um, with problem 11, what you're given is you start with a cube with edge E, and you're told that the total area is equal to 150 units squared. And what you have to do is you have to find the volume. All right? Let me double check that. Yeah, you have to find the edge, and you have to find the volume. Okay. So, knowing the total area is equal to the lateral area plus two bases, I have to just fill in what I know and see what I don't know. So that lateral area we know is the perimeter of the base times the height. Now the perimeter of the base is the perimeter of a square, because a cube is a square prism. So we know that the perimeter of the base is 4e. So there's that, the perimeter of the base 4e. And we know that the height of the cube is also the same as the edge length. So the height, we're going to represent that with an e. And then we have two bases that we have to add to the lateral area, the area of two bases. So we know that the area of any base is e times e, that's e squared, and I need two of them. So I have 4e squared plus 2e squared, that gives me 6e squared. And that is the the total area of a cube, 6e squared. And I know that it's 150 units squared. So I set those equal to each other, divide both sides by 6 to get 25, and I know now that 5 is equal to E. Knowing that, I can use the E5 in the formula for volume. Okay, so here we go. The volume is the area of the base times the height. That's E times E, that's the area of the base, E squared, times the height of the cube, or of the cube, the prism there, is E. So that's E cubed, and putting in a 5 for E cubed, putting in a 5 for an E, substituting, I get that 5 cubed is equal to the volume, and that's 125 units cubed. So that is number 11. Number 16, this is a fantastic problem. You might see this again somewhere. Okay, we have the length, width, and height of a rectangular solid. So it's some kind of a rectangular prism. Everything is tripled, and we want to know what happens to the lateral area, the total area, and the volume. Okay, so we want to know the scale factor. The old, let me represent that by a 1, and if everything gets tripled, let me represent that by a 3. So the scale factor from the old to the tripled new is 1 to 3. Now, we had a theorem a long time ago that said if a scale factor was a over b, then if the solids or the polygons or whatever were similar, then if you wanted to find how that affected the area, you squared it. Okay? So if the solids are similar, and they are, then the areas are squared. So here's the scale factor, 1 over 3, and I got to square both of those things. I get 1 over 9. So anything that has to do with area is going to be multiplied by 9, the lateral area and the total area. All right? Now, the volume, since this lives in space, 3 dimensions, it's the scale factor to the third power. Okay, so here's the scale factor, 1 to 3, and I got to put it to the third power to see what happens to it. That's 1 cubed over 3 cubed, which is 1 over 27. So the volume is multiplied by 27. All right, so that's problem 16. Moving on to 26. This is my favorite problem because it's about horse troughs. Okay, very exciting. A drinking trough for horses is a right trapezoidal prism with dimensions shown below. If it is filled with water, about how much will the water weigh? It's just the burning question of our time. Hint: 1 cubic meter of water weighs 1 metric ton. Okay, so here's my horse trough. Isn't that cute? It's got a trapezoidal base, 2 trapezoidal bases, and what I did was I redrew that. Blew it up so we could see it. Okay, so this dimension here is 100. This is 40. This is an isosceles trapezoid because both of these legs are 50 each. Okay, so this is 40, this is 100. This dimension from here to here, if I drop these altitudes, is also 40. That means I have 60 left over for these little wings. Okay, that means each of these wings is 30. Now, if this is 30, I have this is 30, this dimension here, the leg of the trapezoid, is 50, I can see that this is a 3, 4, 5 triangle that's just been multiplied by a factor of 10. Okay, that's good to know because that means the height of my trapezoidal base is 40. Now, the volume of any prism, I'm switching gears here, the volume of any prism is the area of the base times the height of the prism. Now, the height of the prism is 2 meters. But looky, these are all in centimeters. We're a little bit messed up here, so we should change the meters into centimeters to keep our units the same. So 2 meters equals 200 centimeters. That's good to know. All right, so the volume area of the base times the height of the prism. Here's the height of the prism. Okay, now the base is a trapezoid. So the area of a trapezoid we know from past chapters, 1/2 B1 plus B2 times the height. Which height? We've got lots of little heights running around. This is the height of the trapezoid. Okay, so 1/2, base 1, 100, base 2, 40, and the height of the trapezoid is 40. Okay, so let's see. 100 plus 40 is 140 divided by 2 is 70. 70 times 40 times 200 is going to give me the volume. All right, so 7 times 4 is 28, times 2 is 56, and we have 1, 2, 3, 4 zeros, 1, 2, 3, 4 zeros there. So the volume is 300, what am I thinking? 560,000 cubic centimeters. All right, now what I have to do is I got to convert because I got to figure out how much all this stuff weighs. All right, so here we go. All right, so I take a 1 meter cube, and I want to convert this guy into centimeters. I can do that so that I can do some division here and do my conversion. So if each of these dimensions of this cube is 1 meter, then the dimensions are going to be 100 centimeters, 100 centimeters, 100 centimeters, length, width, and height. Okay, so I know that the volume is length times width times height. That is 1 times 1 times 1 with 6 zeros. 2 zeros, 4 zeros, 6 zeros. 1, 2, 3, 4, 5, 6. So the volume is equals 10 to the 6 centimeters cubed. Okay, so 1 meter cubed equals 1 million centimeters cubed. So if I had the volume of 560,000 centimeters cubed, then to convert that into meters cubed, I'm going to divide everything by a million. Okay, so out go my zeros. 1, 2, 3, 4. What I'm left with is 56 over 100. That's 0.56. 56 hundredths, right? That's where that comes from, meters cubed. So since 1 meter weighs 1 metric ton, then the weight will be 0.56 metric tons. Okay, voila. And now let me get this sucker off.